Good afternoon, everyone. In today's video, I'm going to do principle of mathematical induction. This is there for class 11 CBSE and for ISE students. So, let's start with the chapter, the principle of mathematical induction. Now, a statement will be given to us in the question. We need to check whether the statement is true for n equal to 1. No, the statement is simply a fact. So in order to see whether it is equal or not, whether the left side of the statement is equal to the right side of the statement, we substitute n equal to 1. But it can be 1 or any other number depending on the question. Sometimes if a statement is given where it is said n is greater than or equal to 3, then we take n as 3 to verify whether the statement is true or false. Once you consider the statement is true for n equal to 1 or for any number for which the question is asked for, generally it is for n equal to 1, otherwise for any number that has been said in the question. Now, once it is true for n equal to 1, then the statement is true for n equal to k also. So we assume the statement is true for n equal to k. Once the statement becomes true for n equal to k, the statement have to be true for k plus 1 also. Since we assume that k is true, the liability of proving k plus 1 is also true lies with us. So it's a very simple type question. You get a 5 mark from this. If you have descriptive questions in your exam, definitely this is a 5 mark area. Now, let me just tell you this once again. A statement will be given in the question. Generally, we take n equal to 1, we substitute and see whether left side equal to the right side or not. Then the statement stands proved. So the statement is a fact now. Then you take n equal to k and we assume that it is true for n equal to k. When it is true for k, then it has to be true for k plus 1 also. So using n equal to k statement as an inductive step, we prove k plus 1. Now I have basically divided this chapter sums into 4 types. So let me tell you that. So this is exercise 4.1 from NCERT textbook. The same questions you can find in ML Agarwal also. Now, these are questions in the first page of the textbook of NCERT. The ones that you see me ticked here are all type 1 questions. All these are type 1. Because in all these sums, the terms are expressed in the series. It is expressed as a series. When terms are expressed with plus sign, you call it as a series. So 1 cube plus 2 cube plus 3 cube till n cube is equal to n into n plus 1 the whole square, n into n plus 1 by 2 the whole square. So as you can see, all the terms are expressed as sum of two terms, like it's an addition format. So this is type 1. And if you notice question number 13 and 14, the terms are expressed in product form. Look, 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 4. So this is considered as type 2 model. These two are type 2 model. Then you have questions where we need to prove that this is divisible by 7, a simple statement where we need to prove it's divisible by 11, divisible by x plus y, divisible by 8, divisible by 27, divisible by 3. So this is considered as a type 3 model. And the inequality type, less than, or greater than type, is considered as the type 4. Now, the sums that you see in between, like 12, 15, 16, 17 and all, is type 1 question again. So type 1, type 1, type 1 and type 1. So there are 4 types in which many sums are based on first type. First type is where terms are expressed with plus sign. Second type is where terms are expressed in product form. Third type is where a simple statement is given when you need to prove a multiple by a number. The fourth type is the inequality type. So make a note of this. So these are the 4 major types we need to cover. Now I'm going to make videos on these 2 types one by one. Today I'm going to focus on type 1 model. So there we go. This is the first sum. Proof this by principle of mathematical induction. Now, the first step of the question is assume that the given statement is P of n. So P of n such a way it's 1 plus 3 square so on till 3 power n minus 1 equals to 3n minus 1 by 2. Now let us first observe the question. Terms expressed in a series, the nth term is given to us and sum of this is this, isn't it? The nth term of the series is 3 power n minus 1 and sum of this is 3n minus 1 by 2. So this is what the series says. Now we need to see whether it's true or false. Since we start for n belongs to any natural number in the question, so I'm going for n equal to 1 first. You can try for any natural number, but 1 would be the best choice. And we always do it for 1 until otherwise specified in the question. So let's consider let n equal to 1 and apply n in the place of 1 in the place of n. So P of 1 would be 1 plus 3 square so on till 3 to the power of 1 minus 1 and over here 3 power 1 minus 1 by 2. So I get 1 plus 3 square so on is 3 power 0 and here I get 2 by 2, right? So that means the nth term of the series is 1. The sum of nth term is also 1. You understand? The last term value is also 1. The sum of this is also 1. So only when this is equal, the nth term and sum of nth term value, then the statement is a fact. Now let us prove it in the next way. Now let us assume n equal to k. So when n is k, it becomes P of k such a way 1 plus 3 square so on till 3 to the power of k minus 1 equal to 3 power k minus 1 by 2. So I simply took n equal to k and I substitute k in the place of n. Now I'm going to assume P of k is true for all values of k that belongs to natural number. So I'm going to assume that P of k statement is true. So when P of k is true, P of k plus 1 also have to be true, isn't it? So this will be the inductive steps. Inductive step means this will be used in proving k plus 1. Alright. So assuming that P of k is true. So moving on, let n equal to k plus 1. So then we get P of k plus 1 such a way it is 1 plus 3 square to so on till 3k plus 1 minus 1 equals to 3 to the power of k plus 1 minus 1 by 2. Please understand wherever there is k, I am substituting k plus 1. And that is how this is coming up. So I am simplifying this a little bit. 1 plus 3 square so on till 3 power k equals to 3 power k plus 1 minus 1 by 2. Now what I did so far? Nothing. I substituted n equal to 1 and I said I checked whether the question is true or false, true or not. I found that the question is true. Now what is true? The nth term value and the sum of nth term value are same. So the statement is a fact. Next I took n equal to k and I assumed that it is true for all values of k that belongs to natural numbers. Since I am assuming k is true, the liability of proving k plus 1 also lies with me. So I am taking n as k plus 1 now. And I formed a statement based on that. Now I need to prove that this is true using k statement. Alright. Now let's take only the left hand side of this statement. Let's take only the left hand side of the P of k plus 1 statement, which is 1 plus 3 square so on till 3k. Now please understand when n is k plus 1, the nth term value is 3k, 3 power k. Please make this clear in your mind. When n is k plus 1, the value of that term is 3 power k. So when n is k, the value of that term is 3 par k minus 1. So the term that comes before k plus 1th term is kth term, and the value of that is nothing but 3 par k minus 1. Correct? Yes. So 1 plus 3 square, so on, 3 to the power k minus 1 plus 3 power k. This is a very simple fact. When imagine this is 51th term and this is 50th term. If 51th term value is this, then 50th term value will be this, isn't it? That's it. If k plus 1th term is 3 par k, then kth term is 3 par k minus 1. So I'm just writing the previous term value. So I took the LHS and I'm writing the previous term value. Now, from this to this is sum of 1 to 3 par k minus 1. So that means 1 to kth term sum. We already assumed that it is 3 par k minus 1 by 2. So this is 3 par k minus 1 by 2 plus 3 par k. So 1 to nth term sum is 3 par k minus 1 by 2, and I am adding the k plus 1th term value to it. Alright, now when I add that, the answer must be the sum of k plus 1th term. So let's see whether we are getting the RHS. So 3 power k minus 1 plus 2 into 3 power k by 2. Rearrange the term. 3 power k plus 2 into 3 power k minus 1 by 2. Now take 3 power k common out. It is 1 plus 2 minus 1 by 2. So that means 3 power k into 3 minus 1 by 2. So that means 3 power k plus 1 minus 1 by 2. Now just see the RHS. This is the RHS. Isn't it? When n is k plus 1, this is the RHS, the LHS. We took LHS and we derived. It's equal to the RHS. So P of k plus 1 is also true. Therefore, the statement is a derived fact. So what I did now is the first question, and now I'm moving on to the fifth question. Everything is same, stick to the same steps. Take n equal to 1, check whether it's true. Then take n equal to k, assume it is true, and then prove k plus 1 using k statement. Alright, so now I'm going to do the fifth question. Fifth question. First step, assume the given statement as P of n. So P of n is 1 into 3 plus 2 into 3 square plus 3 into 3 cube, so on till n into 3 power n equals to 2n minus 1 into 3 power n plus 1 plus 3 by 4. Now n equal to 1. When n is 1, P of 1 would be 1 into 3 plus 2 into 3 square plus 3 into 3 cube, so on till 1 into 3 power 1 equals 2 into 1 minus 1, that's 2 minus 1, and 3 power 2 plus 3 by 4. So the nth term value is 3. Let us see the sum of nth term. 2 minus 1 is 1, 1 into 3 square is 9, 9 plus 3 is 12, 12 by 4 is 3. So you get 3 equals to 3. So nth term value and sum of nth term value are same. Therefore, the statement is true for n equal to 1. P of 1 is true. Now n equal to k. When n is k, it is P of n equals or P of k equals. P of k is such that 1 into 3 2 into 3 square, so on till k into 3 power k equals 2k minus 1 into 3 to the power of k plus 1 plus 3 by 4. And we assume P of k is true. We assume that P of k is true, and this will be inducted in P of k plus 1 step. Now, next step is let n equal to k plus 1. When n is k plus 1, P of k plus 1 would be 1 into 3, 2 into 3 square, so on till k plus 1 into 3 to the power of k plus 1 equals 2 times k plus 1 minus 1 into 3 to the power of k plus 1 plus 3 by 4. Now, let us simplify to some extent before we start taking the LHS. 3 square plus k plus 1 into 3 to the power of k plus 1 equals 2k plus 2 minus 1, so that's plus 1 into 3 to the power of k plus 2 plus 3 by 4. So this is n equals to k plus 1 statement. Now this one we need to prove. So let's take the LHS of this, just the left hand side of this, which is 1 into 3 plus 2 into 3 square, so on till k plus 1 into 3 power k plus 1, right? Now, I'm repeating the same important step again. When n is k plus 1, the k plus 1th term value is k plus 1 into 3 power k plus 1, right? Now, that means when n is k, the value of that term is k into 3 power k. So, k plus 1th term value is this. The kth term will be exactly before term, and the value of that is k into 3 power k, correct? So, 1 into 3 plus 2 into 3 square, so on, k into 3 power k plus k plus 1 into 3 power k plus 1. Very simple step. If you're writing till 70th term, the previous term is 69th term. So 70th term value is this one. So 69th term value we insert before that. Now 1 to k term sum, we already assumed it's true. So therefore 1 to k term sum is what? 2k minus 1 into 3 power k plus 1. 2k minus 1 into 3 power k plus 1 plus 3 by 4. And plus the last term, k plus 1 into 3 to the power of k plus 1. Now, never try to expand anything here. Never try to expand anything. Try to take common terms out here. Because in induction, if you start multiplying everything or if you start expanding everything, it doesn't work. Okay? So, 2k minus 1 into 3 to the power of k plus 1 and plus 4 into k plus 1 into 3 to the power of k plus 1 plus 3 whole divided by 4. Hope you understood what I did. I took LCM, so the 4 comes to this place, and then I rearranged the term because I can see that 3 power k plus 1 is common. So 2k minus 1 into 3 power k plus 1 plus 4 into k plus 1 into 3 power k plus 1 and then plus 3. Now taking 3 power k plus 1 common out, it is 2k minus 1 plus 4k plus 4 plus 3 by 4. So that means it is 3 to the power of k plus 1 into 6k plus 3 plus 3 by 4. Now I'm going to take 3 common out from that. So it is 2k plus 1 plus 3 by 4. So now it is 3 power k plus 2 into 2k plus 1 plus 3 by 4. Now this is the left hand side that I am getting. Let us see whether it matches with what I am supposed to get. I am supposed to get this. I am supposed to get this. And I think that's what I found. 2k plus 1 into 3 power k plus 2 plus 3. Plus 3 by 4. Understood? Next is question number 9. P of n 1 by 2 plus 1 by 4 plus 1 by 8 so on till 1 by 2 power n equals to 1 minus 1 by 2 power n. Next we assume n equal to 1. So P of 1 will be 1 by 2 plus 1 by 4 so on 1 by 2 equals 1 minus 1 by 2. So 1 by 2 equals 1 by 2. So nth term value and sum of nth term value are same. Therefore, P of 1 is true. Then let us take n equal to k. When n is k, P of k would be 1 by 2 plus 1 by 4 plus so on 1 by 2 power k equals 1 minus 1 by 2 power k. And as usual, we assume P of k as true and we induct this step in k plus 1. Assume P of k is true. Now, let n equals to k plus 1. So, P of k plus 1 would be 1 by 2 plus 1 by 4 so on till 1 by 2 power k plus 1 equals 1 minus 1 by 2 power k plus 1. Now that's what we need to prove, isn't it? Now let's take the LHS of whatever we are supposed to prove. So LHS is 1 by 2 plus 1 by 4 so on till 1 by 2 power k plus 1. This is kth term value, k plus 1th term value. So what is the kth term value? This one, isn't it? So let's induct that 1 by 2, 1 by 4 plus 1 by 2 power k plus 1 by 2 power k plus 1. Now, sum of terms from 1 to k, we already know that the sum is this. So I'm going to substitute that 1 minus 1 by 2 power k plus 1 by 2 power k plus 1. Now I have to simplify to get the RHS of k plus 1 statement. Okay, let's see. Now 1 minus 1 by 2 power k plus 1 by 2 power k into 2 because 2 power k plus 1 is 2 power k into 2. 2 power k plus 1 is 2 power k into 2. And I'm going to take 1 by 2 power k common out. Here I'll get 1 minus 1 by 2 then. So that will give me 1 minus 1 by 2 power k into 1 by 2. So that is 1 minus 1 by 2 power k plus 1. And see what I'm getting. I'm getting the RHS. Look at this. Hence proved. Got it? 1 is the 11th sum of type 1. First step we assume as P of n. Steps are very important. Don't leave any step. 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4, so on till 1 by n into n plus 1 into n plus 2 equals n into n plus 3 by 4 into n plus 1 into n plus 2. Let n equal to 1. So P of 1 would be 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4, so on till 1 by 1 into 2 into 3 equals 1 by, not 1 by, 1 into 4 by 4 into 2 into 3. So 4 get cancelled. Here also I get 1 by 6, here also 1 by 6. So nth term is 1 by 6, sum of nth term is also 1 by 6. Therefore, P of 1 is true. Now, as usual, next is n equal to k. When n is k, P of k would be 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4, so on till 1 by k into k plus 1 into k plus 2 equals k into k plus 3 by 4 into k plus 1 into k plus k plus 2. This is for n equals to k. And what do we assume here? We assume that P of k is true. Assume P of k is true. Now, next is consider n as k plus 1. So, P of k plus 1 would be 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4, so on till 1 by k plus 1 into k plus 2 into k plus 3. So, I just substituted n as k plus 1 in the question. So, this will become k plus 1, k plus 4 by 4 times k plus 2 into k plus 3. So, all k will replace, all n get replaced by k plus 1. Now, let's take the LHS of this. Left hand side, which is 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4, and the last term is 1 by k plus 1 into k plus 2 into k plus 3. The right hand side of the k plus 1 series. K plus 1 series. Now, this one is the nth k plus 1th term value. This is the value of k plus 1th term, and this is the value of the kth term. The kth term will be the term before this, isn't it? So let's induct that. When I induct that, I get 1 into 2 into 3 plus 1 into 2 into 4 plus 1 by k into k plus 1 into k plus 2 plus 1 by k plus 1 into k plus 2 into k plus 3. Now, sum of 1 to kth term, we already know that, don't we? Yes. Sum of 1 to kth term, sum is k into k plus 1, k into k plus 3 by 4 times k plus 1 into k plus 2. K into k plus 3 by 4 into k plus 1 into k. into k plus 2. Let me check that once again, because if I go wrong, I need to rework it again. K plus 1, 4 into k plus 1 into k plus 2. Plus this term, which is 1 by k plus 1 into k plus 2 into k plus 3. Now try to take common terms out. I've been telling you for all the sums now, do not blindly expand everything. Try to take common terms out. So I can take 1 by k plus 1 and k plus 2 common out from this. Remaining will be k into k plus 3 by 4 plus 1 by k plus 3. Now try to work on whatever we have inside the bracket. So 1 by k plus 1, 1 by k plus 1 into k plus 2. LCM will be 4 into k plus 3, k into k plus 3 the whole square plus 4. So 1 by k plus 1 into k plus 2 into. So let's expand it. Denominator is 4 times k plus 3. Numerator becomes k cube plus 6k square plus 9k plus 4. Right? Right. Now, being a cubic polynomial, this will be divisible by something, and I need to find all the possible factors of that. Now, let's see what I have to achieve. I have to achieve this. Please remember, this is what we are supposed to get. So we aim to get this. So when you see the denominator of the step where we are in, there is k plus 1 and k plus 2, I think, and there is also k plus. There is k plus 1, k plus 2 and k plus 3 and 4. But in what we need to prove, there is no k plus 1. So definitely the k plus 1 should eventually get cancelled. Okay, being a proof sum, it is always mandatory to check what you need to achieve. So in what we need to get, the denominator is only 4 into k plus 2 into k plus 3. There is no k plus 1 in that. So definitely, eventually this term should get cancelled. And being a cubic polynomial, definitely this will get divided by this, provided if you have not made any mistake. Alright, chalo. Let us see. I'm going to divide in rough, not as a fair working, 6k square plus 9k plus 4 by k plus 1. I told you why I choose k plus 1, because in what I need to get, there is no k plus 1. So definitely this will get divided by k plus 1. So k plus 1, so k square. So k square into k plus 1 will be k cube plus k square. So this will get cancelled when you subtract. And here we get 5k square plus 9k. To get 5k square, I multiply with 5k. So this will be 5k square plus 5k. Subtract again. This will get cancelled. You get a 4k. Bring the 4 down and you put 4. So it will be 4k plus 4 is 0. So this is divisible. Now let's go back to our step. 1 by k plus 1 into k plus 2 into k plus 1 into k square plus 5k plus 4 divided by 4 times k plus 3. Isn't it? Dividend equal to divisor into quotient. Isn't it? So dividend equals to divisor into quotient. Now k plus 1 get cancelled. So it is k square plus 5k plus 4 divided by 4 times k plus 2 into k plus 3. Now factorize the numerator. Product is 4, sum is 5. So k plus 4 into k plus 1. divided by 4 times k plus 2 into k plus 3. So we achieved what we need to get. So this is our answer, and let's see whether this matches with the right hand side. Yes, absolutely it matches. So therefore we proved that P of k plus 1 statement is also true. So this is the type 1 model. Hope you understood. Try the remaining sums that I showed you from this book. This is very important. So try all the type 1 questions based on these 4 questions. Thank you.